This paper presents a novel approach for developing ultra-broadband radar infrared (IR) stealth materials based on copper sulfide (CuS), embedded reduced graphene oxide (RGO) aerogels. The authors use different methods to reduce the amount of CuS and adjust the morphology of the material, resulting in different levels of radar cross-section (RCS) reduction. They found that the hydrothermal method produced the best results, achieving an RCS reduction of -60.3 dBm2. Additionally, they also investigated the effect of the filler content on the RCS reduction, finding that the lowest RCS reduction, -60.3 dBm2, was achieved when the filler content was 2 Wt%. This paper demonstrates the potential of using RGO aerogels as a platform for developing radar IR-compatible stealth materials.
This article was authored by Yu Wu, Yu Zhao, Ming Zhou, and others.